Hello everyone, good day all. Today we are going to discuss about a project which I recently worked on um, to build a machine learning model. This is all about we are given with a complete data set from a power plant where the data set includes on an average hourly basis what is the generated electricity, the output. Given there are various weather and the ambient metrics given to us. What you see on the screen, we have temperature, pressure, humidity, vacuum. All these are the available feature for us, and our aim is to predict the electricity output based on the close to around 10,000 various parameters we got as part of the data set. I took it in a different approach. So, broadly classified as four. Hey, what is my approach? How am I going to approach this model or modeling the machine learning or building the machine learning model? That's the right way to put. Okay, so how can we build the base model? What are the various parameters we can look at to evaluate whether this is the right model? When we try to apply various iterations, how can I validate whether which model is doing better than the other one? And based on whatever metrics we collected, how am I going to interpret which one is the best model for us to move forward with and work with the ground team, right? So, as a first approach, what is it we need to do to develop our base model? That's our the first area to start with, right? As a thumb rule, I started looking into multilinear regression and to figure out, okay, so let's apply this, understand whether it's a linear behavior, what when it comes to accuracy, what is the percentage of accuracy we are getting. Just went ahead with training data, test data, split between 80% training, 20% test, applied it, understood, got some metric as an output, evaluated through various metrics like MSE, MAE, and considered that as the base model's metrics. Then want to look at what are the various techniques we can use to further improvise that. One, bring the cross-validation technique into mix so that you don't need to go ahead with one set of training, break it down, okay, training, validation, and then testing. So applied five folds of cross-validation technique and reiterated it, and the metrics improved much better, right? However, we do have other options also. We can vary the features, we can vary the algorithm. So considering we have only four features, I didn't even bother to uh, spend much time on that. Instead, I went ahead and varied various algorithms between parametric and non-parametric. Since we already tested the multilinear regression, I want to apply the polynomial regression and see whether it is improving our model. It actually improved the model, but uh, very much improvement is what I noticed, not that high. Then I kind of want to look into what are other options we can go ahead. Um, and that's where we kind of got into decision tree, random forest, and I also want to see, hey, if we apply neural network, how is that model is going to be? I know our data set is very low. It's around 10,000 different entries. So when I applied the decision tree, and by the way, I went with the maximum depth of 6 to figure out, okay, how is that results gonna be? It is definitely better than the multilinear regression and a polynomial regression, but it's not up to the mark. I think it was around a 94 or 93 range percentage of accuracy. Then I went ahead with random forest regression, right? And a few considerations. I limited the trees to 200. At the same time, I limited the max depth to 10. And at the same time, when I kind of applied that technique, it improved much better. And also, I applied the neural network. I mean, every time when I'm coming up with a new iteration or new model, just capturing all the metrics. Now, for the neural network, three hidden layers of the 64 neurons, 32 neurons, 16 neurons, and ReLU was the activation method I used, and the learning rate kept at 0.001, and maximum iteration was around 1000. And the results looks like pretty linear, and it's kind of seems it is accurate, and it was very difficult for me to understand which one is better than the other one. So went ahead with the metrics, eval metrics. The first set is validation data, and then the second set is the test data. It's very clear. Random forest beat the other models, and I'm sure neural network is a very close, but because of the data set, it was size, it was not that up to mark. Random forest beat the all other models, and but mainly because of the ensemble averaging of the various decision trees. That's a quick snapshot I want to share. Thank you.